My name's Skylar, and today we'll be looking at chromosomal synapsis in two different individuals. Using a racetrack as the chromosomes with colored letters representing the genes, here is individual 1. As you can see, an inversion loop is necessary for this chromosomal aberration in order to maintain gene alignment during meiosis. This is a pericentric inversion, as the centromere, represented by a gray dot, is included in the inverted area. With a crossover event between J and K, 4 possible chromatids will be formed. Here you can see the first path taken by car 1. Here is the second path taken by car 2. Here is the third path taken by car 3. Finally, here is the fourth path taken by car 4. Here are the 4 possible chromatids produced by each of the cars. However, the first and third chromatids will not go on to produce viable gametes due to gene repetition. The second and fourth will go on to produce viable gametes. Now, here is a representation of individual 2. As you can see, there is no inversion loop necessary as no chromosomal aberration is present. Again, there is a crossover between genes J and K, and the 4 pathways are as follows. The first pathway, the second, the third, and finally the fourth. Here's what's produced by each of the pathways. As you can see, all 4 chromatids are the same and will go on to produce 4 viable gametes. Individual 1's chromosomes are involved in heterozygote inversion, meaning that half of the crossover chromatids produced are not viable. Individual 2 has homozygous chromosomes, so the crossover products are all viable and persist. The fitness for the heterozygous chromosomes is lower than the homozygous chromosomes. Homozygous chromosomes produce chromatids that go on to produce viable gametes more often than heterozygous chromosomes.